Okay, I'm going to start because it's already 8 minutes past and we've got limited time. So just a quick recap of what we did last week. Let's just quickly go to new part on this. So essentially it was setup. Remember, we went through the setup options. I hope that you're all able to download or get hold of those new files that I sent. Did anyone have any hassles with that? All okay. All right, so just a brief recap. So under settings here, you could load your ISO modified file that I gave you, and also you could go to the system options and you could go to things like file locations and you could change where your document templates were. So here I've got that's my directory, and you could add ones and you could delete and etc. Okay, so if you have any questions on that, just keep them for now and we'll get to them. Then we went through geometric relations, or essentially best practices in SolidWorks. Oops, that's not going well. Right, and I think I showed you how to set your, what is it called now, gestures up. And some of you or most of you might have been able to capture my gestures. If you weren't, I can actually see if I can send you those settings. If you remember correctly, I basically went through what it means to have a fully defined sketch. So essentially it was whatever you did had to be related to this origin point and hopefully to a center line. So we can pick dimensions. And once a dimension is in, you can type in whatever dimension you want. If you want to change it, you just double click the dimension. And if it doesn't show up a dialog box, you go to the left-hand side here and type in what you want and hit enter. Hit this click button. All right. So here I'm going to dimension from origin to that point there. I want it to be 23. And what I can also do is I can use this update button and just check that what I want is what I actually want. And if it isn't, I can quickly change this to go to something else. And we're done. All right, one last dimension, two last dimensions. Okay, and then I can dimension if you go across a center line, it'll actually double up the dimension. So which is what you should do most of the time. So I've done that. This one you can actually, you should be able to drag this across. You can't. So you can drag this point across. No. Okay, sorry, I'm a bit wrong about that. I mentioned from this point to the center. Yeah, and if we have any kind of relationship that we need to establish, like for instance, I want this arc to be coincident with this line, I can pick point and the line by holding the shift button, and I should get this dialog box, and the top row will show you what relationships are possible. If it's not in here, it's not possible. So I'm going to make this coincident. That means that point is now attached to this line, and you see everything's gone black. Okay, if I try and dimension this line, I'm going to get an error message. There it is. So it says I'm over-defining the sketch. Do I want to make this dimension-driven? Not something I showed you last week, but you can say okay, and then what will happen is that gets grayed out, which means you can't change it. But should I change, let's change this bottom dimension to be 3. You'll see that that dimension there is updated, just to show you what the effect is of your sketch. Right, the other thing we could do is we could select all the elements in a sketch, or all the lines, and you could right click and either go down to one of these commands here, I don't know where it is, or it should be in your little context menu at the top. I'm going to say mirror entities, and it's done it for me. We're done. Okay, I'm just going to redimension this because I want that to be across the center line. All right, that's as far as I'm going to go. Just recapping on this, we'll get, obviously, I'm assuming that you're all going to be super keen to find out how to do your current exercise better. Am I right?
Phil, I have a question with how did you get to highlight that entire part black?
Okay, I'm going to go through that later, and we will go through it. Don't worry. But for now, I want to just recap what we did last week, and then I want to show you some content which I need you to understand, and that will helpfully answer some of your questions. And then in the second half of the lesson, we'll go through the exercise again and figure out what to do better. And then obviously we'll introduce the radii, or the fillets and the rounds. Okay.
Okay, and another problem I had was that now that I've done the twist grab handle, if I go back and try to fix any sketches, when I update the features, like for example an extrude feature, it gives me error messages.
Okay, we'll go through that. No problem. Yes, you're going to get that lots unless you do your sketches right. You'll get plenty of error messages. So we'll go through all of that. I promise. So we've got a bit to get through, hopefully before our session ends. So let's try and get through that. Right, so I've dealt with quickly the recap, geometric relations, introduction. We haven't done a lot of recapping of that, but I'm going to get to that now in our next session here. Right, so I'm actually going to minimize SolidWorks for now and maximize, if I can get to it. Yep, maximize this. Okay. Playing nicely. Okay, this is the program I'm using here is Rhino, just because it helps me to do stuff much easier, and I can set things up, and which I've done. This program is available to you guys to download and use. We can sort of go through that at the end of the lesson. It's my favorite program. It's not the same as SolidWorks in that it's not parametric. And what that means is that if I change a dimension, it won't update. So this is not it's not easily a parametric program. You have to use another program with it called Grasshopper, which is another story. But we're not going to worry too much about that now. I will, however, show you during the coming weeks some of its capabilities, because it really is an industrial designer's sort of tool for all sorts of things. I'll show you what those are. Okay, so it's just, yeah. Oh. Okay, so something weird's happened there. Oops. Right, I've placed everything on one layer, and that's going to be a mess to uncover. So let's just see what I was going to do here. Geometric relations. I'm going to have to sort this out quickly. Sorry. Just give me a sec. Nope. Oops. Sweet. Okay. So let's just go through. Got some stuff missing here. Yeah. Okay, never mind. All right, so let's just go through. Actually, let's do this quickly. These are the relations that you get in SolidWorks. So maybe let's just go through them quickly. I'm going to edit the sketch. Right, so horizontal doesn't show here, but essentially, if you have a look, I'm highlighting this line over here. I can right click. Oh, wait, we're not in the sketch. That's why. Okay, I can highlight that and you'll see that, okay, this is not set up as a horizontal line, but it is essentially horizontal because this bottom line is horizontal. So here's the horizontal symbol. And since I dimensioned that dimension from that line to that line, these two lines here have to be horizontal. But I can introduce that. I can just put it in there. And there you'll see that's horizontal. And there it is there, horizontal. Any questions on this so far? I'm going to go through these quickly just so that, because it's something we didn't cover last week, and it's obviously causing some confusion. So the vertical one should be fairly obvious. Let's just click on this line. You can see there's no relationship shown here. So I can right click on the line and I can select make vertical. Okay, and you'll see that in this existing relationship, suddenly put vertical in there. Okay, there's the vertical one. If I click on it, and in this line properties dialog box, you can click on either of these and it'll show you which of those things are being referenced. So that distance there is that line there. Okay. All right. So let's see. Vertical, horizontal, collinear. Okay. So these two lines here are, because of the way I set this up, they are collinear. In other words, that line and that line are on the same plane. So I'm going to just, what I'm going to do quickly is see if I can't lift this. No, I can't. Draw something quickly. Let's draw a line and draw another line like this. Okay, so for instance, say for instance your two lines that you've drawn were nearly collinear, but you wanted them to be in the same plane. You just click on this collinear line, and now they're, if I move this line, the other line will follow. All right, that works in the vertical plane as well. So obviously if I draw a line and a line, okay, sorry, I'm going to delete. What happened there is because I drew them one after the other in the same line, they actually lined up and SolidWorks put the relationship in for me. So if I say collinear, so what I could do here is I could either put them, make them vertical. No, sorry, it's not going to work. I'll make them collinear. And I now have to remove that coincident relationship. So let me just go back. I'll backtrack so you understand what I've done here. Now watch what I do here. I'm going to click on this line. When I drew it accidentally in line with this line down here, and it introduced a coincident relationship. So coincident just means that similar to the collinear one, something about this line is equal to this line. In other words, that point and probably this point are coincident. No, the whole line and that point are coincident. Does that make sense? So I can draw, for instance, another line from there to there. And if I click on this line, you'll see that if I move it around, it's extending this line. That's because that point there, the point is shared by both that line and that line. Okay, even though it's not showing it. Okay, so I'm going to right sort of left click, but extend from left to bottom, from bottom to top, right to left. Everything within here is now selected, and I can actually, no, you can't. Interesting. Okay, so that is connected, but it's not showing that it is coincident. Okay, let's go with that. There you go. All right. Any questions so far? Is this helping, by the way?
Yes, definitely.
Yes, it is. Thank you.
Is that Gabriel?
Yep.
Myself as well. I think it's
Okay. It would be useful to know if others were being helped as well, sometimes, every now and then. All right, so those are just a few of the relationships. Let's establish another one. Let's go. Let's click on this one. This one called co-radial. Co-radial is simply, it only has to do with circles and arcs. So if I create a circle and I create another one, right, and I want the one to be, I want the two to share the same center points. I can either make those, merge those two, right? That's one thing I can do. Or I can click on these two and I can wait for sorry, no, that's not co-radial, that's concentric I'm thinking of. If I make these co-radial, they'll be the same size. See that? Yeah, the reason for that is when I select two, I don't know if this is going to work. When I select two like this and I make them co-radial, it's really saying not only do they share the same center point, they share the same radius. So see what happened there? I've actually joined the two. Okay, I'm going to do that again. So I'm going to create an arc out in the middle of nowhere here. Okay, and now I want that arc to be sharing the same center point. Those two there must share one another, and I want it to be the same diameter or radius, in this case radius. So if I click on this arc and that arc and I say make co-radial, that's what it does. And now I can actually drag that point and that point. And no matter what I do with this, I can't move it around. In this drawing, the only way I can change that is to change this dimension. With me, everyone?
Yes.
Okay. Let's do that.
Yeah.
Okay,
All good.
so
All good.
all good.
Sorry.
Okay, so the next one, I think perpendicular. I'm hoping this is one that you'll understand already. It's one that you're not going to use a lot because most of this program works on perpendicularity, but let's just say you've drawn one line at an angle to another, and you actually want to sit perpendicular, which just means at 90 degrees. If I make it perpendicular, it is now perpendicular. It doesn't matter what I do with this line, it'll stay perpendicular to that line. There's that perpendicular symbol, and there it is. Okay, good on that one?
Yes.
Yeah.
Right, so maybe just on this point, I'm going to get to this a bit later, but this dimension, when you see a dimension like this and it has extension lines like these ones here at the end, that one or that one, the fact that you have extension lines that are parallel to one another means that whatever they're dimensioning is also parallel to one another. And it also implies if you've got another dimension which is kind of at right angles to that, that these two lines are perpendicular. Okay, so I don't even have to introduce this perpendicular relationship. It's there already. It's assumed that that is what is happening. Okay, so obviously if I draw something like that, if I dimension from that point to that point, if I do this sort of dimension, that's a legitimate dimension, but it's not telling me anything other than that point and that point are 8.99 millimeters apart, and that they're parallel. It's not telling me what the true length of this line is. See that? Now we'll get into this a bit later. I'm digressing now. Okay, so back to like that. So let's stop doing that. So back to the next relation is parallel. I'm hoping that this is also by now obvious. Two lines. Let's go like that and like that. Are parallel when obviously they're parallel. I don't know what else to say about that one. That means that the distance between them at any point is always the same. So if I dimension there and there, that's the dimension, 32. Okay. These two lines are obviously parallel. If I put parallel in, nothing's going to happen that will change other than it'll give me the parallel symbol, which wasn't necessary, but the same thing would happen here. So there's no parallel symbol here, and there's no parallel symbol here, and I can put parallel in, and I'm simply stating what's obvious. These two are parallel. Happy with that? So yes. All right, so I'm not going to go through the parallel Y, Z, ZX, and I think it's So along Z, I'm not going to go through those for now. That has to do with 3D sketches, which we aren't really concerned with right now. So here is the one relationship which I think everyone's having trouble with. Tangency is something that you should strive for most of the time. Now, there are instances when you're not going to want tangency, but get rid of that. Most of the time, you're going to want it. So I'm going to quickly create this. Okay. What I can do now, if I want to put a 3-point arc in here, is I can go from one point to the other, and I can make it larger or smaller. Let's make it larger. Okay, so that's a legitimate shape to want someone to make. But in most of what you're going to be doing, this relationship here, the relationship between that line and this arc, is one in which you're going to want it to be tangent. All that means is that if I were to draw a line perpendicular to the center point of this arc, that line would be perpendicular to that line, and that line would be perpendicular, although you can't do it, to, let's just introduce another line here. Right, so, wait, let me show you this. This will be easier. Remember last week I showed you that SolidWorks has this ability to draw a line perpendicular to whatever it is. I mean, tangent to whatever arc it is that you've got set up. Okay, so watch what happens. If I put in that line and I now draw another line which is perpendicular to this line, it'll go to the center point. So these two are, there we go. Before even introducing trying to introduce perpendicularity, it's actually introduced it for me. There's the little perpendicular sign. And why is it? There it is again. Okay, so these two lines are automatically perpendicular. So that's what tangency means. Tangency simply means that whatever arc that you've got is in a relationship with the line that it's at, in a way that they are both perpendicular to this joining line. So I mean, I could make that line, can you see that that line and that line are equivalent, as that line and that line are equivalent? Does that make sense to anyone?
Yes, sir.
Okay, I tell you what, I'm actually going to reverse this just to show you exactly how that works. Because once you understand this, okay, now if I drag this point around, which I can do, drag that out. Like if I drag that point, that's not going to work. If I drag this point around, there we go. It's actually snapped to that point, and now that line and the line underneath it are lying on top of one another. So I can just write. Let's just pull this in a bit. I don't know if you can see there's a point here, and that point indicates the end of that construction line that I put there. In fact, I'm going to drag this out. Let's drag that out. Now you can see that the construction line and the actual line are on top of one another. And here, let's make one of these solid. And there are, in fact, two lines here. If I drag, you can see line 27 and line 30. So there are two lines there. And one of them is solid and the other one is, show me, just delete it, the other one is that. So that's the relationship. And the easiest way to introduce it is to click on the point that connects these two lines and to just hit this make tangent, and it's done it for you. Right, no questions? Everyone happy with that?
Phil,
Yeah.
could you just go back and just show me that last section, the last like 10 seconds of your of moving the.
This one
Could you just
here?
show me the last 10 seconds? Yeah, that's the one.
This one here?
Yes, sir.
Okay, so if I click on any point here, you'll get automatically, you'll get this dialog box appearing. Okay, and at the
Yeah.
top, the top line indicates what relationships are possible with that point. Okay, so in this one, I can make that point horizontal, vertical, collinear, etc., etc. So in the connection between this arc and that line, if I click on the point, it's going to say, there's a line and there's an arc, and the possible relationships here are tangent, fixed, or I can introduce a dimension. So if I just click on the make tangent one, it makes a tangent.
Okay, now I'm with you. All right.
Are you with me?
Thank you.
So it's a neat way of quickly doing anything. In fact, anything you want, you should be able to instantly get all of the possible commands, or at least the possible relationships, and some of the commands. These should also all be possible. All of the possible things you can do with it in this little, I call it context dialog box. I'm not sure if that's the right word. Okay, right, so concentric we've dealt with. Midpoint I think is fairly obvious, but let's just go into this one. Space mouse is not working. There we go. Okay, so I'm going to draw a line just straight up. And let's say I want that point to be midpoint of this. So I can select the line, and I can select this line here, and I can say, no, I can't, sorry, if I select the point and the line, I should be able to make them coincident or midpoint. So if I make the midpoint, it will not connect the two, but it'll put, it will. Okay, sorry about that. So now it's actually connected the line and it's placed it in the middle of this line. So I can't now drag this line. I can do nothing with this line. It's connected in the middle. Okay, so I can do the same thing, by the way, with should be able to do it with this point. There we go. Okay, let's just go back, and I can actually make that concentric, which puts it in the middle. Right. And coincidence, we'll just place it on the line. Everyone happy with that?
Yeah.
Okay, let's see what else we have. Intersection, coincidence I've dealt with, and symmetric. I think that's about the sum of it. I'm not going to deal with the rest just yet. Okay, so this seems to be, I think, I don't deal with intersection much, but I think it's got to do with points. A point is something actually a very useful command. You can place a point anywhere you want, and you can use it to create all sorts of things. But if I want that and that to intersect, I just click them both. No, that's not doing it. 2 lines and 1 point. Oh yeah, it's got to read my notes here, not my notes. These are notes taken from a website by Javelin. Intersection of lines. Ah, okay, right. So, okay, I do use this a lot, but I just don't use it in the way that that I'm actually, that's made sense to me yet. So I'm going to quickly do something here. I'm going to introduce a fillet. So let's say 5 mil at that point, and it's at that point. So what you'll notice is that this dimension here, 23, has now, because I removed the intersection between this line and that line, and these 2 lines here, 1, 2, this dimension says, aha, that intersection's gone. I'm going to introduce a point which marks the intersection of this line and that line. Okay, so let's say, for instance, that we didn't have these, and this is the drawing that you had, and you wanted to mark where these 2 lines would theoretically intersect so that someone's got an idea what the relationship is between them, especially the dimension. If you select those 2 holding the shift key, so I'm going to do that again, I'm going to go click, hold, shift, click, and I put the point in, it'll actually yes, okay, so there you go. It's actually put it in. I had to click there to make sure. Right. No, that is right. It's not. It's not linked. Okay, it is right in the sense that in fact it shows the intersection. So let's say I put a point in. Let's go put the point in again. I can wait for this to line up. So I can click. I can wait for that to highlight. And it is actually putting that line at an intersection between these 2. But if I want to fix, there you go. Okay, so if I want to fix that point as being the intersection between those 2, I have to click on all 3. 1, 2, and 3. And there I get the intersection relationship done. So let's do that again. Let's put a point in here. In fact, I'm going to put it off to one side. So it's not, in fact, in line with this horizontal line. Click, shift, click, shift, click. And you should then be able to click the intersection and watch when I do that, what happens to that point? It jumps to being in line with the horizontal line. And now I can use those 2 points to dimension that point there. Okay, and the only problem I've got now is that these 2 are not collinear, I think. It should still do it. All right. Typically, you would dimension these 2. There we go. Okay, so it's over-defined. So I'm just going to make it driven. All right. So why this is not fully dimensioned is that I haven't given this radius a dimension. I should fix it. Nope. Oh, there we go. Okay, and I haven't put in tangent points. Right, just watch this. So I've clicked on that point, and you can see at the top here it says symmetric. And the moment I go to make tangent, no, I haven't done it. Oops. Right, I'm a bit stumped. I'm not sure why this is not fully defining. It should fully define that coincidence. Okay, never mind. So this is one of the instances where what I showed you last week would help. If you can't figure out why something is not defining fully, then you can use that command that I showed you, which, by the way, some of you found out, very clever, where that is. It lies here in the dimensioned relations box. Here it is here. Fully defined sketch. If you drag that into this box, it'll do it. I'm not going to do it because I've got it there already. But if I go like this, and then I make sure that all of these are selected, and that my origin points are points for the dimensions. Okay, so now SolidWorks thought that this dimension was somehow important. Okay. So my whole sketch stopped being fully defined because of that point. Just reintroduce that. So that's the only dimension it introduced. And that's the sole reason why it would not dimension it. I mean, would not complete the sketch. Bit of that. Okay, everyone's happy with that.
Yeah.
And then symmetric. I think you understand symmetric. Should I go through it? So these two lines and that center line are symmetric. By implication, because I mirrored that half of the sketch across that line, but I can go and define it. So I can put that in and there it introduces it. So that actually works with just about anything. So let's say I want these two to be symmetric around this line, but I want to make sure that this line has an angle to it already. If I click on that line, the center line, the other line, I can either go to the control button and it will show me all the relationships, and there's a symmetric button. Once I do that, these two are in fact at the same angle. So in this case, I want them to be not only at the same angle, but at the same height. So I'm going to click on these two and put in a horizontal, click on these two. Right, before I do that, watch, I can still move this point up and down, but you'll see that those 2 points stay attached to one another, right? So if I want this point and this point to stay attached to one another, I click that, and now the only way I can do this is I can move this in and out. But whatever I do to this line also happens to the other line, because it's in a way fully defined. The only thing I'd need now is to define that 6 and that. Okay, and then I need this point. I also need one from here to there to define the height. Like 30. And now all I need is for this point to have a relationship to that point. So I can either drag this whole lot down like that, or you can see that this is already in a relationship with the origin point because it's black. So it's coincident. I can just introduce this dimension and it goes black. Right, so this entire sketch, even though I can't use this top bit of the sketch, is now fully defined. It's exactly what it should be, what all your sketches should look like. Everything should be black. Other than, I mean, this point here, you can, if you want to, you can actually link it up with this. It's not going to make much difference. And that one as well, we can just. Questions? No. How many people? Yeah.
No, I just said no, sir.
You got it. Is this
Yeah.
this answering some of your questions about how these sketches work and how to fully define them?
Yes,
Yes, definitely.
Is that good so?
yes, it is.
Good so. Okay, so have a look at my fix. Right, we're not going to deal with that now. Maybe I'll just quickly show you what fix does. Right, looks like we're going to be ending this meeting in 5 minutes, and we haven't even covered half the ground we should have. Oh, my goodness. Never mind. Right, so fix is just if you have for some reason you might want to use a sketch in some way. Just delete that. I'm going to set it off in space here, so it's got no relationship. See, it's completely blue. I might want to use that sketch usually as a construction geometry. I might want to use it in a way in which I don't want people to move it easily. So then I would just make this fixed. So you see now it's fully defined. Well, it's actually not fully defined because I can actually stretch the length of the thing. But I can't move it anywhere. I can't even dimension this to be somewhere else. It's going to say it's overdefined. There we go. See that? That's because I've put that fixed relationship in there. And if I release that fixed relationship, now I can actually, and define the two relative to one another. There we go. All right. So it looks like we are going to, wait, what's the time? Oh dear. So our next meeting is supposed to start in 4 minutes, but I think we need a break. So I think what I'm going to do is I'm going to cancel that meeting and send you another meeting request for 15 past 2. Is that okay with everyone?
Yes, sir.
All right, so I'll see you then in 15 minutes and enjoy your coffee. And yeah, if you've got any questions, just write them down and let's see if we can deal with them when we come back. Okay, see you a bit later.
Thank you.
Okay, cheers.